Well, student, today I will discuss about the basic concept of group theory. This unit is very important for your entrance exam like CSIR-NET JRF, GATE, BARC, TIFR and other entrance exam. My name is Chandan. In this unit, I will cover basic point of group theory. So, I would like to suggest you, please keep your notebook and pen with you. You have to write down some important point I will discuss in this unit. Then you can find the point group of the molecule in easy way. So now I will discuss. In this unit, I will cover the point group, types of symmetry element, how to operate the symmetry element on the molecule and classification of point group. Point group is a collection of symmetry element, or we can say is a combination of symmetry element present in the molecule is known as point group of the molecule. For example, CNV, CNH, DNH, DND, tetrahedral TD, octahedral OH, icosahedral IH, etc. Types of symmetry elements. In group theory, only 5 types of symmetry element are present. Identity, which is denoted by E, principal axis of symmetry, which is denoted by Cn, plane of symmetry, which is denoted by sigma. It can be classified as 3 categories such as vertical plane of symmetry, which is sigma v, horizontal plane of symmetry, which is denoted by sigma h, dihedral plane of symmetry, which is denoted by sigma d. And other symmetry elements are inversion of symmetry I, improper axis of symmetry, which is denoted by Sn. Now, what is identity symmetry element? Identity element are present in all the molecules. That means all molecules have own identity. If you are rotating the molecule by n times, you will get same identity molecules, where n is the number of rotation and can be identified by following rotation relation: n equal to 360 degree divided by theta. See, you have your own identity. Suppose your name is XYZ. XYZ is your identity, right? Now I will discuss about the principal axis of symmetry, which is denoted by Cn, the rotation which pauses along with the axis. It can be operated n minus 1 times in the molecule. So you have to write down operation of principal axis is equal to Cn n minus 1. If you are operating the principal axis of symmetry n times on the molecules, you will get identity of the molecule. For example, a water molecule, first by rotation 180 degree, you can see here H1 and H2 exchanged by each other. If you are doing same operation by 180 degree, you can see here H1 and H2 is again changed by each other. Okay, so in first structure and last structure, you can see both are identity. So you can say C2 is equal to identity. As you can see, the above transformation by operating the symmetry element on the water molecule 2 times, we got the same molecule. Hence, principal axis can be operated only n minus 1 times during the operation of symmetry element. Remember one thing, higher order of rotation will be the principal axis of symmetry in the molecule. For example, in a molecule having C2 and C3 axis of symmetry, then principal axis of symmetry will be the C3 axis. Plane of symmetry. This is decided on the basis of bisecting the atoms and reflecting the atoms in the molecule. As I told you before, it has been categorized in three parts of the following assumption. Parts by the following assumption. The vertical plane of symmetry. When the plane of symmetry is parallel to the principal axis of symmetry, then it is called a vertical plane of symmetry. You can see here C2 is the principal of axis and there is one plane of symmetry which is parallel to the C2 axis is known as vertical plane of symmetry. The horizontal plane of symmetry. When the plane of symmetry is perpendicular to the principal axis of symmetry, then it is called a horizontal plane of symmetry. You can see this is a thin molecule and there is C2 is a principal axis of symmetry and there is one plane of symmetry which is bisecting all the 6 atoms, 4 hydrogen and 2 carbon atoms. This is perpendicular to the C2 axis is known as horizontal plane of symmetry. The dihedral plane of symmetry. For the dihedral plane of symmetry, there must be two C2 axes which is perpendicular to the C2 axis. In this molecule, there is two C2 axes which is perpendicular to the principal axis C2, and there is one plane of symmetry which is called dihedral plane of symmetry. Inversion of symmetry, which is denoted by I, imaginary point with the 3D space of the molecule which can invert. It is known as center of symmetry or inversion of symmetry. For example, you can see here in this molecule there is inversion of symmetry is present. The improper axis of symmetry as an imaginary axis passing through the molecule, rotation on which by angle theta degree followed by perpendicular reflection gives an equivalent orientation is known as the improper axis of symmetry. Improper axis of symmetry Sn is equal to Cn into sigma h. You can write down this formula. You should be careful by operating the symmetry element on the molecule. In all this case, by the symmetry element, by operating the symmetry element, molecule must be identical. Operation of symmetry element, you can fix a coordinate of the axis for your convenience. Suppose this is x-axis, y-axis and z-axis. Now we will see one by one how to operate the symmetry element on the molecule or axis. X1, Y1, Z1 and C2 x-axis. We are operating C2 symmetry element along the x-axis. It changes to x1 minus y1 minus z1, and again if you are operating C2 along y-axis, it becomes minus x1 minus y1 and z1. From the above expression, you can see how to change the coordinate by operating the symmetry element. On applying first C2 along x-axis and then C2 along y-axis to a general point, the value of x1 is minus x1, the value of y1 is minus y1 and the value of z1 is z1. If now we apply C2 along z-axis to the general point, it is shifted to minus x1 minus y1 z1. Thus we can write C2y into C2x is equal to C2z. Similarly, on operating the plane of symmetry, we will get, see, suppose x1, y1, z1 is the coordinate axis, okay? And if you are applying sigma xy, x1, y1 and minus z1, it will give. If you are applying sigma yz, it will give minus x1, y1, z1. Similarly, if you are applying sigma xz plane, it will give x1 minus y1, z1. Now we can see on applying C2 along x-axis and followed by plane of symmetry along yz plane to the general point, the following transformation takes place. x1, y1, z1. If you are operating C2 along x-axis, it will give x1 minus y1 minus z1. If you are applying sigma along yz plane, it will give minus x1 minus y1 minus z1. Hence, by the above transformation, you can see all the coordinates are inverted from the main axis. That means inversion takes place by operating the C2 followed by sigma on general point. Thus, we can write C2x into sigma yz is equal to I. Property of commutation are given as two rotation about the same axis, reflection through plane perpendicular to each other, the inversion and any reflection or rotation and reflection in a plane perpendicular to the rotation axis, 2C2 rotation about a perpendicular axis. Now we will see the operation of symmetry element on the molecule. For example, AX3 planar molecule. You can see here, this is the molecule AX3 which is planar, and if you are operating C3 principal axis along Z axis, all the surrounding atoms are interchanged by each other, right? And again, if you are applying plane of symmetry along YZ plane, you can see here A and X1 is retention on the position, and X2 and X3 are exchanged by each other. This is called vertical plane. And if you are applying sigma xy plane which is perpendicular to C3 axis, you can see here all four atoms are bisecting by sigma xy plane. This is called horizontal plane. In the above transformation, you can see by rotation of 120 degree we got the same molecule, and after deflection we got the same identity molecules. Hence, the molecules contain a plane of symmetry and principal axis of symmetry. In this molecule, two types of plane of symmetry are present. One is vertical plane and another is horizontal plane of symmetry are present. From this concept, I would like to suggest you please try to solve this problem. In next video, I will discuss all these problems and some important question from the last year. Okay, and rest of the topic I will discuss in the next video. So what is the question here? Identify the plane of symmetry and axis of symmetry in the monochloro dichloro isomer of cyclopropane. Find out the axis of symmetry and plane of symmetry present in mono, di and trichlorosubstituted benzene. Write the cis and trans isomer of dichloroethene and find out the number of principal axes of symmetry. Write the following transformation. What will be the product if you are operating C2Z into sigma xz? Okay, and for any molecule, if you know the structure of the molecule, you can easily find the point group of that molecule. Okay, I hope you are doing well. Thank you for watching. If you have any clarification or any doubt, feel free to contact me. Thank you, and please don't forget to subscribe my channel. Thank you.